Hello, now we are going to look at simplifying algebraic fractions. And to begin with, we're going to start with non-algebraic fractions. So how would we simplify, or put in its simplest terms, 12 all over 8? Well, we would look for the highest common factor. And this is going to be the same when we're dealing with algebraic fractions. So what is the highest common factor of 12 and 8? It's going to be 4. So we make a note of what our highest common factor is because it's going to get a lot more complicated in algebraic examples, but we want to lay down this groundwork now. So we have the highest common factor is 4. Well, there's a few ways that we could write this. We could say we divide above and below by 4, and we can do that because dividing above and below by 4 ends up being the same as dividing by 1. So it doesn't change the number, so we'd be able to write down that that was going to be 3 all over 2. But there's other ways that we can write that. Sometimes we would put lines through things if we had lots of numbers to deal with. So we might put a line through that and we'd say that we know we're dividing by our highest common factor of 4. So we end up with 3 here. We divide out here and we end up with 2. So we write down the results. And you would still end up with 3 all over 2. However, what's actually going on, or probably the more fundamental description of what's going on here, is that we are taking out the common factor. We are factorizing the top and factorizing the bottom of these numbers. What we are saying is that if the highest common factor is 4, that means we can write 12 as 4 by 3, and I can write 8 as 4 by 2. Well, this looks a lot like the result of fraction multiply, top by top, bottom by bottom. So I can write this as two fractions multiplied together, 4 all over 4 multiplied by 3 all over 2. I have taken out my highest common factor from both of my numbers, and I've said that this is equivalent to saying 4 all over 4 multiplied by 3 over 2. If I went back a step, this would just be fraction multiply. Well, that's just 1 by 3 all over 2. 4 all over 4 is 1. Any number divided by itself is just 1. So I'm left with 3 all over 2. This is fundamentally what's going on in both of these methods. This is showing the reasoning. This is showing the background reason why these other ways of writing it work. And when we want to think about this in terms of algebra, where looking at common factors becomes a lot more complicated, it is useful to think about it in this way. Can I take out a common factor from all of the stuff on the top line and a common factor from all of the stuff on the bottom line, and then take it out as a fraction multiplied by everything else? So 4 all over 4 is 1. Can I write the highest common factor all over the highest common factor is 1 in any situation where I want to simplify my fraction? If I can't write it in this way, I can't take out a common factor. I can't divide out the factor. So let's look at this again. We're going to use this method here. So what's our highest common factor of 10 and 25? Well, that is going to be 5. So I'm going to rewrite 10 and 25 in terms of that highest common factor. So 10 is 5 by 2, and 25 is 5 by 5. So I can rewrite that as this is fraction multiplied, top by top, bottom by bottom. There's no significance to not having the brackets there. So top by top, bottom by bottom, doing effectively the reverse of fraction multiply. I end up with 5 all over 5 multiplied by 2 all over 5. Top by top, bottom by bottom would get me to this line. So these must be the same thing, which is 1 by 2 all over 5, which is just 2 all over 5, 2/5. Now I can start to do the same thing with algebra. So I have 15 A, B. If I have letters sitting next to numbers, it means multiply. So I have 15 by A by B divided by 9 by A. So what's the highest common factor there? Well, what I do is find the highest common factor of the numbers, just like I did for my number examples, and then individually find the highest common factor for each of the letters. So my highest common factor of the numbers, well, I have 15 and 9 here. So the highest common factor there is going to be 3. So my highest common factor is 3. And my highest common factor of the A's, well, I have A to the power of 1. So I have 1A and I have 1A down here. So that is a common factor. I have a factor of A on the top and the bottom line. I don't have a b on the bottom line, so I don't have a common factor of b. So that's my common factor is going to be 3a. So I write down 3a, and 3a times what gives me 15ab, same as what I did here. If I have highest common factor of 5, 5 times what is going to give me 10? Well, it's going to be 5 by 2. So here I have 3a times what gives me 15ab. Well, it's going to be 3 by 5 is going to give me the number. So 5 is the number there. A by a, I don't need to do anything there, but I have a b there. So I have 3a by 5b. If I multiplied that back out, I get 3 by 5 is 15, and a by b would give me ab. So that gives me the correct top line. And on the bottom line, I have 3a. And what do I need to multiply the 3 by to end up with 9? I need to multiply by 3, and I already have my a there, so there's nothing else to multiply. So this is the same as 3a all over 3a multiplied by 5b all over 3. Well, 3a divided by 3a is just 1. It doesn't matter what a is, because the a's must be in the same thing. So I have a number divided by itself, so I'm left with 1 by 5b all over 3, which is 5b all over 3. You can write down the by 1 if you wish when you are starting out, but you don't need to in the long term, unless you're finding that you start making mistakes. So that's how we do this. We look for the highest common factor of the numbers as before, and then individually the highest common factor of the letters, write that out, and then we have any number divided by itself is 1, and that allows us to simplify. Now, if we have powers involved, it's useful to remind ourselves of what powers mean. So if we have x to the power of 2 sitting next to y to the power of 3, that means x by x multiplied by y by y by y. We can write that out the long way. So that's all of my x's multiplied out. So I have x to the power of 2 means x multiplied by x 2 times, y to the power of 3 means y multiplied by y 3 times. And that means they're all multiplied together because they're sitting next to each other, with no pluses or minuses in between. Now, here we have a more complicated fraction to simplify, but we are going to do it in exactly the same way. We have the highest common factor. So the highest common factor of our numbers we start with, well, 4 and 36, the highest common factor is going to be 4, because 4 by 9 is 36. And then for the letters, we look to our a's, and we have a cubed here, so that means a by a by a. And down here we have a to the power of 1, or a by itself. So we only have one a, or a to the power of 1, that is a common factor. And then we have x squared all over x cubed. So we have x by x on the top and x by x on the bottom. So we have two x's multiplied together would be the highest common factor there, because x cubed would be x squared, x to the power of 2 times x. So we can write down our highest common factor, 4ax squared times what is going to give me 4a cubed x squared. Well, 4 is fine. A by what would give me a cubed, that would be a squared, and x squared by what would give me x squared, well, that's just by 1. So a squared is all I need there. And write down my common factor again, times what is going to give me 36a cubed. Well, 4 by 9 is going to give me 36. A by a, so that's just 1. And x cubed and x squared times what would give me x cubed, well, that would be by x. So I have this divided by itself. So I can write that down, 4ax squared all over 4ax squared. That's just 4 divided by 4, a divided by a, x squared divided by x squared. That's all just simplifying to 1 over a squared over 9x. So I end up with 1 times a squared all over 9x, which is it simplified. It's worth noting, as this gets more complicated, there's another way that you can write it. So this is an aside. When we figure out what our highest common factor is, we can divide it into this piece here. To figure out what has to go in this second bracket can sometimes be challenging. So we can actually write it as a separate fraction. So we have a cubed all over x squared divided by what we figured out was our highest common factor. That's to the 1 if you want, or x squared. So I've written down my highest common factor and I'm dividing it into this because a result of this division is what goes in that bracket. So 4 divided by 4 is 1. A cubed divided by a is a squared. X squared divided by x squared is 1. So that's another way that you can think about figuring out what has to go in this bracket by writing out the division explicitly. So that is not part of the main solution to the problem. That is just a reminder on how it is you can figure out what goes in your bracket here. So now we have a more complicated situation. Before we had a single term on the top and a single term on the bottom. Here we have terms added together. Now we only have a single term on the bottom here. So what can look like we could do here? So this is wrong. Do not take this down. This is wrong. We could use like our line method here and say, well, we have 4 divided by 4. That goes in once, and we'd write that down x minus 2 all over a squared. Now this is very wrong, and we're going to look at why it is very wrong now. But it's very easy to think that that would be what you needed to do if we weren't writing things out in terms of the common factor. Because how have we been simplifying our fractions? We had to take out a common factor from the top line and the highest common factor from the bottom line. Well, what's the highest common factor of the terms that are on the top line? Is 2. So I can write that as 2x, 2 times 2x minus 1 all over 4a squared. So I take out the highest common factor of the top line, and if I had a sum of terms like I do here, take out the highest common factor there. Now I see that I don't have a highest common factor of 4. I do not have a highest common factor of 4 top and bottom. I only have a highest common factor of 2. The only factor that is common to everything on the top line and everything on the bottom line is 2. So my highest common factor is just 2. It is not 4 like it might look like if we just started crossing off terms. I need to be able to write this as 2 times everything on the top line, because that's the highest common factor of the top line, and 2 times everything on the bottom line. And if I can do that, then I can do my business of having 2 divided by 2 times everything else. And 2 divided by 2 is 1, so I'm just left with 2x minus 1 all over 2a squared. And that's as far as I can go, because there is no common factor beyond that. Now here, let's try and write out our common factors. On the top line, we have a highest common factor of 2. So we have 2, and we have in the letters, we have a highest common factor of x. So we have 3x minus 7. Again, if you want to check your answer, multiply it back out and see if you get the same answer. Or divide each term by your highest common factor. But what's our highest common factor of 12x minus 1? Well, it's just 1. We could take out a common factor of 1, but it didn't really help us in this particular case. So we can't do anything with that. There is no common factor other than 1 in the top and the bottom line. There's nothing that is a factor shared by everything on the top and the bottom line. So that's as much as we can do. That's as much as we can factorize that fraction, even though it looks like there might be a factor of 2 going on. Because this is just minus 1, we can't do anything with it. Finally here, let's take out the highest common factor on the top line and the bottom line. When we do that, we see that we have 9m as the highest common factor on the top line and 3m squared as the highest common factor on the bottom line. And we can write this out the longer way as we did earlier on. But our highest common factor here is not our highest common factor here. So we have a second step. What is the highest common factor between these two now that we can see they're the highest common factor on the top line? Now you can do this all in one go. You end up with 3m as being the highest common factor, but this can be quite hard to see just trying to do it with all 4 terms. So we can do it in 2 steps. We divide 3m by 3m and get 1, and this is our final answer. And that is what we need for now.